So hello guys, welcome back. Today I will discuss the paper 2 of JEE Advanced 2025. So here is the first question. If you have not tried this question, do pause and try it out. Okay, so now I will start solving this. In the first step we are given that x naught is a real number and e power x naught plus x naught is given to be 0. So we are required to solve this big function g of x. So I will write it down for you guys. So here is the function g of x. What I've done is I've just manipulated this a bit to make this small, and this comes out to be x minus alpha times e power x plus x divided by 3 times e power x plus 1. Now if we look at the question, so in all the options we have been given this expression, which is limit x tends to x naught g of x plus e power x naught by x minus x naught. Now actually this, I don't think this mod will play any significance, because this, if we actually apply L'Hopital's rule to this, then this will come out to be as g dash x. So basically we have to solve g of x or differentiate g of x and then find out. So what we will do is we will try differentiating g of x now as g dash x. So this is the normal process. This will come out to be as 1 minus, I will take this alpha by 3 outside. Now e power x plus x will come out to be as e power x plus 1 when I differentiate this part, and keeping this constant, this becomes a square minus of, now this will come out to be e power x plus x into e power x, and this, if I put this in a bracket, this is whole divided by e power x plus 1 whole squared. Now as you can see, as we have been given this limit value, and eventually we actually have to find g dash x naught. So what I can say is this part is actually e power x naught plus x naught, or rather for any x naught which is real, this expression has been given, which is 0. So I can put this whole thing directly to 0. And now this and this on dividing, they will get cancelled. So basically our g dash x is nothing but 1 minus alpha by 3. So now we are only required to find g dash x naught or g dash x. It's the same thing, which is 1 minus alpha by 3. So now if we look at the options, if we put alpha equals to 2, so basically it will come out as 1 by 3, which is not in the options. And if we put alpha as 3, then this will become 1 minus 1, which is 0. So basically our option C is the only correct answer. So this was a pretty simple question. We will head on to the next question now. Okay, so here is the next question. So this is basically another question. This is not very difficult. This is a question on areas, as it is obvious. So we have the following curves: x, y greater than 1, 5x minus 4y greater than 1, 4x plus 4y less than 17. So what I will do is I will try graphing out these points, I mean these curves, and then we will try to find the problem. So here is the approximate curve for this particular question. This, I have noted these curves as C1, C2 and C3, and as you can see, the curve C3 is 4x plus 4y less than 17. So basically I will try to denote by arrows. So basically for this question, I mean this curve, we are denoting this part. So if we take the common area for this particular curve set, then this will come as the area. So this is the required area which actually the question has asked. So now this point is 17 by 4 comma 0, which is pretty obvious, because this 4x plus 4y, this is the straight line, 4x plus 4y equal to 17. So basically if we put y as 0, so we'll get x as 17 by 4 comma 0. So we need to find two more points. One is the point Q, which is the intersection point of these two lines. So basically we have to solve these two lines, and this is the point P, which is the intersection for this line C2 and the curve x equals to 1 by y. So first I think we will find P. So here is the calculation part. I have done all the calculations for you guys. So basically what I have done is y is from here, y is 1 by x. This is simple stuff. I have just substituted this value into curve C2 and then found x equal to 1. So basically we actually don't need the y coordinate of P, so I haven't found it and wasted my time, because these things are actually important. What you find and what you not find in the exam hall can give you some seconds to spare for another question. Now in this particular curve, 4x plus 4y equal to 17, I have done the same thing as earlier. So S, this point where actually C1 or C1 actually meets C3, this point I have named as S. So this is 4 comma 1 by 4. I have calculated it. And for point Q, I have just added these two equations, and so we have got y equals to 9 by 4 and x equals to 2. So now our basic observation from this part is that if we have to find these two areas, we actually have to subtract the area of two trapeziums. I will draw it for you guys. So I have roughly tried to show what we have to do. So basically this shaded region and this shaded region, I have shown this blue line because it was too small in the diagram. So basically these are two trapeziums. Now if we have to actually calculate the areas of these two trapeziums combined together, and then subtract the area which this curve C1 xy equals to 1 is subtending in between this 1 to 4. So as soon as we do that, we will actually get the required area PQS. So now let's move on to the calculations. So now we will move on to the calculations part. So we can directly find out the areas. So the area of a trapezium is half into sum of the parallel sides into the height. So half. Now I'm doing it for this trapezium. I have not named it, sorry. This and this trapezium. So for the first trapezium that you see, the sum of parallel sides is basically 1 plus 9 by 4, because if you actually put xy equals to 1, x coordinate 1, so this will come as 1, and this height is 9 by 4, we have already found this, into 1, because the distance between these two is 1, plus half into this is 9 by 4 and this height is 1 by 4, into the distance between 2 and this is 2 basically, because this is 4. And now this is the combined area of these two trapeziums, and now we will basically, as it is pretty obvious, we will subtract from this total area this particular part that I am showing with the pen, because this is the area that is being subtended by xy equals to 1. So basically it is very easy to find. It will be integral 1 to 4 dx by x. So now I will do the calculation. So this was some pretty easy calculation stuff. If you see, this is 13 by 4 and into half will give 13 by 8, and this thing is 10 by 4, into half will give 10 by 8, and into 2 will give 20 by 8. And this thing is actually very simple to find because this is ln x, so ln 4 minus ln 1 is 0. So this is basically 13 by 8 plus 20 by 8 minus ln 4, which is 33 by 8 minus ln 4, and I guess it is option number B. So this is the correct answer to our question. So this was also a pretty easy question, I guess, on areas. Now we will move on to the next question. So here we move on to the next question. So basically this question is, I guess, a very good question in this paper, because the problem here is that, as most of you guys can see, I will just write out the question once. This is theta equals to tan inverse 2 tan theta minus half sine inverse. Now if you divide this particular bracket whole throughout by 9, it will come out to be as 6 by 9, which is 2. I write this tan theta by 3 separately. This is 1 plus tan squared theta by 3. So basically this is 2 tan alpha by 1 plus tan squared alpha, or rather you can say this is sine inverse 2x by 1 plus x squared. Now the problem here is that we don't know anything about the range of x. That is, as you guys know, sine inverse 2x by 1 plus x squared, this is not simply tan inverse x, and that's where most of you might make a mistake. Although we will see later on in this question that actually we do not need the other two ranges, but JEE Advanced could do anything to actually make this question complicated by introducing solutions in the other two ranges as well. So it's mandatory that you check all three and you remember all three in the exam hall. So basically this is 2 tan inverse x, I'm sorry, when minus 1 is less than equals to x is less than equal to 1. Now this becomes pi minus 2 tan inverse x, as you guys know, as x greater than equals to 1, and now this will become minus pi minus 2 tan inverse x when x is less than equals to minus 1. So basically this is the complete frame for this. So first we will try to manipulate this a little bit and then we will start introducing these one by one. So I will manipulate this now. So here is the form. Now basically this particular bracket I have left this open because we will have these three inside this. So I will take the first case at first, simple first case, which is 2 tan inverse x. Here please note that here x is tan theta by 3. So in the first case I am taking minus 1 less than equals to tan theta by 3 less than equals to 1, or rather you can also say minus 3 is less than equals tan theta is less than equals 3. So what I will do is I will just write this simply as 2 tan inverse of tan theta by 3. So this 2 and this 2 get cancelled. So we have tan inverse 2 tan theta minus tan inverse of tan theta by 3. Now what I will do is, because we will be requiring this tan theta multiple times in this question, so instead of writing tan theta I will take this tan theta to be some constant y. In this question whenever I write y, just remember that it's tan theta. So I will change the page. So this is what it becomes, tan inverse 2y minus tan inverse y by 3. So this is basically a very simple formula that all of you know. This is tan inverse x minus tan inverse y, which is tan inverse x minus y by 1 plus xy. So this is 2y minus y by 3 divided by 1 plus 2 by 3 y square. So if we solve this a bit, this will come out to be tan inverse 5y by 3 divided by 1 plus 2 by 3 y squared. So now what I can do is, as this is equal to theta, I forgot to write, so we can basically move tan to this side, and again we will have tan theta, so I am writing it as y, which is equal to 5y by 3 by 1 plus 2 by 3 y squared. So this will be y equals to 5y by 3. This 3 and this 3 on taking the LCM will get cancelled. So this is 3 plus 2y squared. So what I can do is, I will not cancel out y. This is a very common mistake because we know that y equals to 0 is also a solution. So I will write that y equals to 0 is one of the solutions, and then I will strike it off. So basically from here we have 3 plus 2y squared as 5 and y as plus minus 1. So as tan theta or y lies in between minus 3 to 3, so all of these solutions are accepted. So basically from case 1 we will have 3 solutions. Now the lucky case for this question is, if any of you in the exam hall have done just this, like you didn't know, or what most people do is they forget the other two cases. If you have actually tried only this case, then your answer is actually correct. The answer is actually 3 solutions. I will tell the option later on. But in provisional answer keys, you will actually have, although they never publish the answer key altogether, but actually with the fundamentals you should also check the other two solutions, because not this time, but if in any other paper in the next years JEE repeats this question, there is a high probability that they can actually give you the case 2 and case 3 as well, and maybe you will have 1 or 2 solutions there. So we will check all the solutions, all the cases at a time. Now we will proceed on to the next case. So this is the next case for this question. As I had written down above, we have x greater than equals to 1 or tan theta greater than equals to 3. So I will write this basically as tan inverse y. Okay, this was, I'm sorry, this was 2 tan theta. So this is 2y. And this was minus pi by 2 plus tan inverse of this 2 and this 2 will get cancelled. So this is y by 3. So what I will do is I will take this to the left hand side. So we have theta plus pi by 2 equals to tan inverse of 2y plus tan inverse of y by 3. So this is basically again the same simple formula, tan inverse of x plus tan inverse of y. So this will come out to be as 2y plus y by 3 by 1 minus 2 by 3 y squared. So basically if we manipulate this, this will come out to be, I guess, 7y divided by, on taking the LCM, this is 3 minus 2y squared. And now, like earlier, we actually shift this to the left hand side. So we will basically have tan theta plus pi by 2, which is equals to 7y divided by 3 minus 2y squared. Now actually this step that I have done is wrong, and I guess most of you had mistook it and overlooked, because if you observe here, we have another deduction that this x and y, if we add to y plus y by 3, basically this is 3 to the 6 7y by 3, which is greater than 1. So as you know, we have to introduce a pi here also, because this will become pi plus tan inverse of x plus pi by 1 minus xy. This is a very major mistake that most of you guys will make. So actually, if we shift this pi to the LHS, this thing will become theta minus y by 2, which is equals to 7y by 3 minus 2y squared. Now you know that tan theta minus pi by 2 is nothing but minus cot theta. So this is minus 1 by y, which is become 7y divided by 3 minus 2y squared. So now I will basically just cross multiply. So this has become 2y squared minus 3 equal to 7y square. So finally we have 5y square equals to minus 3, which is not an acceptable equation. So we will have no solutions from here. And that's why this is the lucky charm in this question, that you actually can solve from the first step itself. Although we will see the next step as well, you will get a similar result. I will show you the next step in a glance. So here is the third case to the question. I didn't waste time in solving this because I think you guys can do it. I have done this also for your reference. Actually, you will see that this and this equation in case 2 and 3 are actually same. So from here also you will have no solutions. This is for tan theta less than equals to minus 3. So basically our final answer is option C, which is 3. So if you guys actually get this type of question, you don't know in the exam hall, so you have to solve case 2 and case 3. Although you will understand later that in this question it is a waste of time, but you don't have any options. Okay, so we'll proceed to the next question now. So here is our next question. This is also a very simple question where we actually need to find out the point of intersection of these two pair of lines, rather the locus. And after that, we have to solve the tangent. And basically our slope is given, so it will be easy. Now, at first, let's see what the conic comes out to be. So the equations are 4x minus 3y equals to 12 alpha and 4 alpha x plus 3 alpha y equals 12. So what I will do is I will at first multiply this with alpha and this with 1. We'll solve it for you guys. So this will become 4 alpha x. So I will subtract these two equations and this will become minus of 3 alpha plus 3 alpha y, which is 6 alpha y, and this is 12 alpha squared minus 12. So basically if you see carefully, y will come out to be 2 into 1 by alpha minus alpha. I'm just taking the minus to this side, so it's 12 minus 12 alpha squared by 6 alpha. So this is the value of y. And then we can also actually easily find out x from this particular equation. What you have to do is, if you want to eliminate y from here, you have to multiply this equation again with alpha and this with 1 and basically add these two. So you will have 8 alpha x as equal to 12 alpha squared plus 12. So from here x comes out to be, I guess, 12 by 8 is 3 by 2, and this is alpha plus 1 by alpha, and our y is 2 into 1 by alpha minus alpha. Now I received one solution that we can actually multiply these two equations and alpha will automatically get eliminated, but what I would recommend is don't go for experiments in the exam hall because there's already crisis of time. So what we will do is the very simple basic fundamental thing to eliminate alpha from here is squaring and subtracting, because this is alpha squared plus 1 by alpha squared and this is also alpha squared plus 1 by alpha squared. We will have a plus 2 here and a minus 2 here. So basically what I will do is I will take 2x by 3 to this side and y by 2 to this side and then square it up for you guys. So after squaring and subtracting, this is what it becomes, and the RHS, it will become alpha squared plus 1 by alpha squared, which is 2 times, so it will get subtracted, and here we have plus 2 minus of minus plus 2, which is 4. Now if we put this 4 to the top and then divide this 4, bringing this down, it will come to be x squared by 9 minus y squared by 16 equal to 1. So basically this is a hyperbola with small a equals to 3 and small b equals to 4. So now the question is pretty simple. Now we have the line 4x equals to 3 by root 2y given, and basically we have to find out the tangent, and this tangent is parallel to this line, so y will be basically 4 root 2 by 3 x. So this is the value of slope for the tangent. Now as all of us know, y equals to mx plus minus root under a square m square minus b square. This is the standard formula for the tangent for a hyperbola, so I will quickly solve it down. So this is the final equation for our tangent, and I have manipulated this for you guys. So basically we were needed to find these 2 points lying on the tangent, so very simple. We have to put, for p we have to put y as 0, from where we will get x as 3 by root 2, and for q we will put x as 0, from where we will get 4. Okay, this is p, and we won't take plus minus 4 because q is greater than 0. This is mentioned in the question clearly. So I guess we are required to find the value of pq, which is 4 3 is 12 by root 2, and if I multiply root 2 in the numerator and denominator, this comes out to be 6 root 2. Okay, and I'm sorry, there is a minus here also, so this will be minus 6 root 2, which I guess I will tell you the option. So the correct answer for our question is option A, which is minus 6 root 2. So this was a pretty simple question, but yeah, if you don't remember this equation, then I will say you are doomed, because there is no time to solve this paper. Actually, the paper afterwards contains many questions which are very difficult and lengthy. So if you want to do them, then you should remember this particular equation. So yeah, this was a simple question. We will move on to the next question now. So this is our next question. Now what I will say is this question can be solved very easily using the eigenfunction, but as eigenfunction is not presently in the JEE syllabus, so I will try to solve it using the conventional method only. So basically we have 3 matrices, P, the identity matrix, and Q, and we have a condition given as QR equals to RP. So I guess we have no other options but to apply this condition, QR equals to RP, and also before that I will take R as to be some, say, alpha, beta, gamma, and delta. So we will try to multiply this now. So this is what we get on multiplying. So basically this question now seems very lengthy. I guess there are a lot of variables, but after a while you will realize that it is very easy. So if we manipulate the RHS, relatively easy, this will be 2 alpha 3 beta, and this will be 2 gamma and 3 delta. And for the LHS, this will become x alpha plus y gamma. This part will become x beta plus y delta. This becomes alpha z plus 4 gamma, and this becomes beta z plus 4 delta. So now we have some equations. I will try to write them down. This is x alpha plus y delta equals to, sorry, this is not delta, this is gamma. X alpha plus y gamma equals to 2 alpha. This is x beta plus y delta equals to 3 beta. And I guess this equation will be a little simpler. Alpha z plus 4 gamma is 2 gamma, from where we will actually get a relation that alpha z is minus 2 gamma. And another equation is beta z plus 4 gamma equals to 3 gamma, which I am writing all together as beta z equals to minus delta. So what I will basically do is I will try dividing these two equations. So what we get is alpha by beta equals to minus and minus gets cancelled, so gamma by delta. Okay, the 2 is also remaining, I guess. Yeah, so this is it. Now what we will basically try doing is we will try to substitute these values into these equations and solve it to get something good. So in this step what I have basically done is I have manipulated the first equation, which is x alpha plus y gamma equals to 2 alpha, and the second equation, which was x beta plus y delta equals to 3 beta, and I have written these two and divided so I can eliminate y. Now what you will see is we have gamma by delta and alpha by beta this side. So if we take gamma by delta to this side, this will actually become this expression, I guess. Yeah. So basically we have 2 minus x by 3 minus x. If you compare with this one here, it is basically equals to half. So if we multiply both of these sides, this will become 4 minus 2x. Now x we have as equal to 1. So this is the value of x we are having. So now the sum is not ended, I will show you. So I have another idea in this question. What we will do is we'll actually try to use this. Now as you know that we in matrix form we can't cancel out this r and r, but if we take mods on both sides, then this will become mod q mod r equals to mod r mod p, and now we can actually cancel mod r and mod r because this is a numeric quantity. So basically mod q is equal to mod p, and if you look at p was this 2003, so mod p will basically be equal to mod q, which is basically 6, and mod q, which is q is x y z 4, so mod q is 4x minus yz, which is equal to 6. Now we already know that x equal to 1, so if we put this here, we will get the yz as minus 2, which is option number D given as yz equal to plus 2. So automatically our option D gets wrong. So we'll try to manipulate this now. So from this point of the question, we actually have two methods of solving this question. One is you can use the CI characteristic equation for this particular matrix, which is Q. This will be n squared. I will write down Q for you guys once. This is x, y, z4. So this is n squared minus, so basically this part is the sum of x and y, which is basically 5n, and this will become the products, which is 6 equals 0. So from here we will get n as 2 and 3, and if you look in carefully, the characteristic equation for this matrix Q is actually equal to mod q minus ni. If you know characteristics equation, then this method is for you, otherwise I will show another method also. So this is equal to 0. So basically for n equals to 2, 3 and so on, you will actually get the value to be 0. And I guess we have that mod q minus 3i or 2i in the question. I will figure it out later. And the second process for this question is what you can do. The qr equals to rp, you can use this result once again. What you can do is you can subtract, say if you want to find out some nr, you can subtract nr from this side and also from this side. So basically what will happen is you will have q minus ni. If we take the mod on both sides, then mod r will get common and cancelled from both sides, and this is mod of p minus ni. So basically, if you put the subsequent values for n, you know p, and therefore you can find out the values. I will find the values for you guys. So I will review the options for you guys once. We got D as wrong. And now in C, it is written Q minus 3i as 15. You can calculate it from this part, but as I have already done using the characteristics equation, that any ni will be 0. So basically our option C is also wrong. But Q minus 2i is 0 given in option A, so this becomes correct. And now for option B, we were required to find mod of Q minus 6i. So basically, in this particular part, we can only use 2 and 3. So for 6i, we actually have to find mod of p minus 6i. So first, p minus 6i, this particular matrix will be 2 0 0 3 minus 6 times an identity matrix, which is basically 6 0 0 6. So this comes out to be minus 4 0 and I guess minus 3. So mod of p minus 6i, as you can see, minus 4 into minus 3 becomes 12, which is same as mod of q minus 6i, and this is given in option number B. So option B is also correct. So the correct options for this are A and B. So you can either, I guess this method will be a little simpler for those people who don't know characteristics equation, and actually this method is more recommended because you will only get 2 and 3 here, but for 6 you have to solve this extra. So why not write this in the same time and then put the values and solve. So this question is done. Now we will move on to the next question. So here is the next question, and I guess this question was the hardest question in this year's JEE Advanced, because this question is something whose pattern you will not notice maybe in your PYQs, and this was a really good question. So we will try solving it. So basically, I will read the question once. Here we have S denoting the locus of the midpoints of those chords of the parabola y square equal to x. So I will draw a parabola. Okay, I'm sorry. This will be the parabola y squared equal to x. And now we have the area of the region enclosed between the midpoints of this chord such that the area between the parabola and the chord is 4 by 3. So basically we need a chord like this whose midpoint is some h comma k that we have to find. And I guess we have no more information. We only have y square equals to x and that the enclosed area is 4 by 3. So basically the question becomes difficult because we actually have to take a lot of variables and solve this. So as you guys know, here in this particular thing we have y square equals to 4ax. So a is basically 1 by 4. So we can take this point P as the general point in a parabola is t square comma 280. So I will take this to be t1 squared comma t1, and I will take this to be some q which is t2 squared comma t2, sorry, it's t2. Now from this what we can infer is, as this is the midpoint, h comma k is the midpoint, so from midpoint formula we can say t1 squared plus t2 squared by 2 equals to h. So basically 2h is t1 squared plus t2 squared, and 2k is basically t1 plus t2. These are the two fundamental equations. Now we will need a third equation as well because we can't eliminate this t1 plus t2 from here by any means. Either we need t1 minus t2 or something like that, because you have done this type of stuff in many chapters. So we will use this area concept here. So basically if we see the x coordinate of this point q here is t2 squared and this thing is t1 squared. So basically if we try to write out the area for this, this will be integral t2 to t1, and okay, I'm sorry, this is actually, I have to denote the y as well. This is t2 and this is t1. So we are basically trying to find out the area along the y-axis. That is why I have taken it as t2 and t1, because if you take t1 squared and t2 squared as the limits, then the mountain amount of calculation after this will get more enormous, so it will be a dire headache for you. So I guess this is better. Now this will be x, the curve on the right, minus x, the curve on the left side, dx, and this is given to be 4 by 3. So basically we have to find out this equation, and we already have the curve on the left to be as x equal to y squared. So we have to find out this equation. Now we have a standard formula for this particular equation of when the midpoint of a chord is given, but because this is not in the standard form, this point, so what I will do is I will calculate it using the 2-point form of a straight line. I will calculate it for you guys. So here is the equation for this line PQ. I've just applied nothing but the 2-point form. So if we move over T1 plus T2 to this side, and actually one T1 squared will get cancelled. So basically this is the equation. Now if we punch this into this particular integral, this becomes T2 to T1. The right side is the line, so I will basically try writing that out using a couple of brackets. This is T1 plus T2 into y minus T1 T2, and this is minus y squared dx. Okay, I'm sorry, this is not dx, this will be dy. Yeah, and this is given to be 4 by 3. So basically we have to manipulate this big thing. If we try integrating this, this will become T1 plus T2 into y squared by 2 minus T1 T2y minus y cubed by 3, which is from T1 to T2. So this is where the question actually becomes complex, because after this there is a heavy amount of calculation, after which you will only actually get the locus of this point M, and the question is not over. Then you, after you get this locus of the curve S, you have to find another area. That's why this question is getting pretty long, and this is a very difficult question. You will understand with the manipulations. I will do it out for you guys. So this is the manipulation part after we put the limits and all. So what I have done is I have basically taken T1 minus T2 out of all these parts because it is common. So we have T1 plus T2 squared by 2 minus T1 T2 minus 1/3, because this was whole cube. So this is T1 squared plus T2 squared plus T1 T2. So what I will do is I will try to manipulate this inside a little bit. So this is T1 minus T2. Now if we open up this bracket and bring this 2 here, this will become T1 squared plus T2 squared minus, sorry, plus 2T1 T2 minus 2T1 T2. So this is T1 squared plus T2 squared by 2. And we have minus of 1 by 3 T1 squared plus T2 squared plus T1 T2. And this is basically given as 4 by 3. So if we take the LCM from this part, this is what comes, the big expression. Now if you see, if we subtract this, this becomes T1 squared plus T2 squared minus 2 T1 T2. So basically this is T1 minus T2 whole squared. So it is actually shortening down, and we have by 6 here, which is equal to 4 by 3. So if we shift this 6 to this side, this is 24 by 3, which is 8, and this is T1 minus T2 whole cube, which is equal to 8. So basically our mod T1 minus T2 has come out to be 2. Now we are actually ready to use those two results, that is T1 plus T2 equals to 2k and 2h equals to T1 squared plus T2 squared. Now we can actually use these two results to find out the locus. So what I will basically do is I will square and add up these two equations. So as we know, this is T1 squared plus, sorry, this is not T1 squared, T1 plus T2 whole squared plus T1 minus T2 whole squared. This is equals to 2 times T1 square plus T2 square, because 2T2 and minus, sorry, plus 2T1 T2 and minus 2T1 T2 will get cancelled. Now we know the value for this as 2h. So I will basically write this as in one step. this is 4k squared plus 4 equals to 4h. So if we cancel out all the 4's and substitute y and x in place of k and h, we will get y squared equals to, we will move this thing to this side. So it will become y squared equals to x minus 1. So this is actually the final locus that has been referred to in the question as S. So now we will proceed on to the options. So in option A, we basically had if 4 comma root 3 belongs to this curve, that is, it lies on this curve or not. So if we apply 4 comma root 3, I guess it is, just a minute. So yeah, root 3 squared is 3 and 4 minus 1 is 3. So 4 comma root 3 lies on this curve. So our option A is correct. Now 5 comma root 2, which is the other option, I guess that will be wrong because this is 2 and this will become 5 minus 1, 4. So option B is wrong. Now we'll proceed on to the question once to solve the rest of the two options. So basically now, as the question says, we have to find out the region R that is enclosed between this curve S, which is actually a parabola, between the parabola y square equal to x, and they have taken two lines, x equal to 4 and x equal to 1. So I will draw out the graph. So this is basically a rough graph of what has been asked. So now one thing which has been mentioned in the question is that we don't need to find this part. We only need to find the first quadrant's area. Otherwise, this is a symmetric curve. We could have easily found this part and just multiplied it by 2 because these two areas are symmetric. So what I will do is I will directly solve. So area R will be integral. Okay, this is 4. This is x equal to 1 and this is x equal to 4 somewhere here. So this is 1 to 4, and we have y equals to root x minus of y equals to root x minus 1 dx. So now if we integrate this particular expression, we will have 2 by 3 x power 3 by 2 minus 2 by 3 x minus 1 power 3 by 2 from 1 to 4. And if we put the values now, okay, I can take this 2 by 3 outside. So basically we will have 4 power 3 by 2. For this it will become 1 power, okay, for this it will become 1 power 3 by 2, which is 1, and this is 3 power 3 by 2. So we can simply write this as 2 by 3, and 4 power 3 by 2, if you write this as 2 squared, this is 2 cube, which is 8, minus 1 is 7, minus 3 power 3 by 2 is 3 root 3. So if we multiply this comes out to be 14 by 3 minus, I guess, 2 root 3, which is our option C. So basically option D is wrong. So for this question, the correct answers are option A and option C. So this question was hard because it involved a lot of manipulation, and basically this type of a question hasn't been asked in JEE Advanced so before. So you can note this well. This is a very good question. So I think we will proceed on to the next question now. So here is the next question. This question was a very simple question. It is based on very fundamental concepts of coordinate geometry. So I will read it out once. We have an ellipse which is x squared by 9 plus y squared by 4 equals to 1. And now we have a circle x squared plus y squared equal to 9. This is basically, if you guys have read properly, this is the auxiliary circle of the ellipse, whose equation is x squared plus y squared equal to a square. So they have, although they have written this, but they could directly say that it is the auxiliary circle. So if you don't know the name, maybe it could cost you the question. So yeah, I will try to draw out the diagram roughly for this question now. So here is a rough diagram for this question. This is the auxiliary circle. I guess this is a circle, you can see. This is the ellipse, and I have also marked out the points given, which are P, Q, R and S. Now as you will see, M is the point 3 comma 0, which is actually the positive end of the major axis. Now we have been given something about the angles, that angle SOM is pi by 3 and angle ROM is pi by 6. So basically this is to find P. As you know that any point on an ellipse can be taken to as A cos theta comma B sin theta, where this theta is the parametric angle of that particular point. Like for example, if we have P here, then for P, this line that is passing through the point P lying on the ellipse and touching the auxiliary circle at this point R, from R a line joining O, and this particular angle ROM that is formed will be the angle of parameter for this particular P, or you can say parametric angle. Similarly for Q, if we notice, the line will be drawn to the origin from the point S, so the angle SOM will be the parametric angle for the point Q. So basically, if we find out the point P, as we have ROM as pi by 6, I will write out the values of A and B. Here A is 3 and B is 2. So basically the point P will be nothing but A cos pi by 6 and B sine pi by 6, which is 3 root 3 by 2 comma 1. And similarly, if we look at the point Q, this will become, as per the angle SOM given to be pi by 3, this is 3 cos pi by 3 comma 2 sine pi by 3, which is basically 3 by 2 comma root 3. So yeah, and now we can also find the points R and S. So basically R and S are pretty simple to find, because P has the x coordinate 3 root 3 by 2, so R will also have the same x coordinate as 3 root 3 by 2. And you can either put this in this equation of the circle and solve, or you can directly take it as A cos theta comma A sin theta. That is 3. A means, here the A means the radius, I will say R rather, because A is already present, so it is R cos theta comma R sin theta. Here R is 3. So for the point, okay, this is not Q, this is R. For the point R, as angle ROM is pi by 6, so this will become 3 cos pi by 6 comma 3 sin pi by 6, which is 3 root 3 by 2 comma 1. Similarly for S, the angle is 60 degrees, so it will become 3 cos 60 or 3 cos pi by 3 comma 3 sin pi by 3, which is 3 by 2 comma 3 root 3 by 2. So basically we have to actually work with all these points, so we have all the points ready. Now we will try moving on to the options. So basically, while solving option A and B, we are being set to find out the equation joining P and Q. So basically, this is, I guess, this is not a straight line. PQ, the straight line is here. This is the part of the ellipse. This is the equation that we are needed to find. I have represented that with a star. So we have points P and Q, so you can actually apply 2-point form to find this, but what I will do is, we already know that there is an equation to find out the straight line equation for chords joining 2 points if we know their respective parametric angles. So I will write that out for you guys. You should actually know this equation, although in the exam hall, if you don't know, you can apply 2-point form, but while studying coordinate geometry, you should know this. This will be x by A cos theta 1 plus theta 2 by 2 plus y by B sine of theta 1 plus theta 2 by 2 is equal to cos of theta 1 minus theta 2 by 2. If you want the proof for this, this is actually present in a lot of popular books. And if you want the proof for this particular question, you can get it in any book, or otherwise, if you request, I will solve that in a later video maybe. So this is x by 3 cos, now theta 1 and theta 2 are basically 60 and 30. So 60 plus 30 by 2, both of these will be 45. So what I am doing is, I am writing that out as cos 45, which is 1 by root 2. So this becomes x by 3 root 2 plus this becomes y by b is 2 and sine 45, so 2 root 2 again, is equal to cos of 90 minus 60 by 2, which is cos 15 degree, and cos 15 degree is root 3 plus 1 by 2 root 2. So what we can do is, we can actually cancel out root 2's here, And if we manipulate this, we will take the LCMs. This will become 2x plus 3y, and this becomes 6. So if we take this to this side, it will get cancelled. So this becomes 3 times, because here we will have 6. So basically this will cut as 3. So this will be 3 times root 3 plus 1. So the correct answer to this is option A. So automatically our option B gets wrong. Now if we move on to option C and option D. Okay, I have to write the values of x1 and x2 maybe. So here, if you look at these points and the question once, you will get that x1 is this particular thing, 3 root 3 by 2. And I guess x2 will be 3 by 2. So if we take the point n2 as x2 comma 0, which is 3 by 2 comma 0, and we have the point s as 3 by 2 comma 3 root 3 by 2, then n2s will become, as the x coordinates are same, so it is the y coordinate distance, which is 3 root 3 by 2. And if you find out n2s, sorry, we have found n2s, so n2q. For n2q, n2 is 3 by 2 comma 0 and q is 3 by 2 comma root 3. So the x coordinates are again same, so this is root 3. So basically 3 times mod n2 is 3 root 3 and 2 times n2s is also 3 root 3. So our option C is correct. Now we will check on for option D. For option D we have n1 as x1 comma 0, which is 3 root 3 by 2 comma 0. And n1p, the distance, I guess it will become, because x coordinates are again same, so this distance has become 1. And for, I'm sorry, this is not 1, this is 1. n1r will become, n1 and r, if you observe, their x coordinates are also same, so it is also 1. So basically n1p and n1r are equal quantities, but here we have some 9 n1p equals to 4 n1r, so D is wrong. So our correct options for this question are A and C. So basically this was a very fundamental concept based question. Okay, so this question was a very fundamental question, and if you guys actually observe, these things are all taught to you in basics of coordinate geometry. So yeah, I guess this will be the final question for this video, otherwise this will become too long. So I will be solving the next questions in the next videos, and if possible I will attach them in the description as well after uploading. So yeah, keep watching and do like, share and subscribe for more. Thanks for watching.